Okay, welcome. Today we're going to look at solving trigonometric equations. This is chapter 5.3 in your text. So go ahead and pull your notes out and we'll get going. At any point in the video, if you feel like you're falling behind, make sure you pause the video and get your notes caught back up. Or if you didn't quite understand something the first time, make sure you pause the video, rewind it, and listen to that piece again. Sometimes it takes a couple times through to understand the concept. Our objective for this video is students will solve trig equations with one trig function that require factoring. Okay, let's go ahead and get started on our first example. Our first example is 2 sine squared x minus sine x minus 1 is equal to 0. And we're looking for all the solutions over the specified interval from 0 to 2 pi. All right, let's go ahead and write this problem down. Now, the first thing I see when I look at this problem before I start my solving process is I notice it's a quadratic because it's a power of 2. There are 3 terms. So I'm thinking in my mind, how do we solve quadratics or trinomials? Now, if I think back to polynomials, so here's what I'm thinking. Here's my thinking bubble. If I were to substitute out the sine squared and replace it with any variable, I'm going to use the variable u. So if I said u is equal to sine, this would be 2u squared minus u minus 1 is equal to 0. Now the whole purpose of just using the u is just to make it look like something I recognize. I do recognize how to solve that. That looks like factoring to me. So now I'm going to use my factoring techniques to go ahead and finish this problem. Now, I may factor different than you factor. There's multiple ways to factor. Use the way that's most comfortable for you. So here's the method I'm going to use. I'm going to go ahead and put my x over here. And I'm going to multiply the leading term, which is 2, to the constant, which is negative 1, and I get negative 2. And I want to find factors of negative 2 that add up to the middle term coefficient of negative 1. Now the factors of 2, there's only one set, that's 2 and 1. So in this particular problem, we have a negative 2 and a positive 1 because negative 2 plus 1 is negative 1. Now to finish off my factoring method, I'm going to divide through by the leading term coefficient, which is 2, and simplify where necessary. So I can see that this side is simplified as far as it can go. We have 1/2. The other side can simplify to negative 1. These are the 2 factors I'm going to use to finish factoring this problem. Okay, so to factor the problem, I'm going to come over here and set some parentheses up. And my first term I notice is sine squared. To get sine squared, I need sine times sine. So I'm going to write sine x, close parenthesis, sine x, close parenthesis is equal to 0. Then I'm going to just go ahead and write in my numbers. I'm going to take the positive 1/2 and put them here. So this is plus 1/2. And the negative 1 and put them in here. And I'm almost done factoring. And I remember using this method. Anytime I have a fraction, I have to take the denominator and write it in front. So I have 1/2. So I'm going to move the 2 to the front. This is 2 sine x plus 1 times sine x minus 1 is equal to 0. Now I'm kind of out of room, so I'm just going to kind of make that my side work, and I'm not going to be able to fit my minus 0 in there. But now we're factored, and now we've reached the form in solving. Remember, you were using the zero product property. We have 2 expressions being multiplied together, and the result will be 0. So to solve, we're going to have to figure out what value of x will make each expression equal to 0. Okay, let's go ahead and figure out what those expressions would be. So we're going to take each expression or each factor and set them equal to 0 and solve. So I start on my first factor. This is 2 sine of x plus 1, and I'm going to set it equal to 0. And I'm going to go ahead and solve it. So I'm going to go ahead and subtract 1 from both sides. And then I'm going to divide through by 2. So I have sine x is equal to negative 1/2. I've now isolated the sine x, and now I can see, using my unit circle, what angles that I can take the sine of and get negative 1/2. Now I'm going to do the same thing for the other factor. This is sine x minus 1. I'm going to set it equal to 0 and solve by subtracting 1 to both sides. And now I have sine x is equal to 1. Again, the trig function's isolated. Now I can see what angles do I take the sine of and get positive 1. Okay, I'm now looking at my unit circle, and I'm going to write my angles over here. I need where sine of some angle is equal to negative 1/2, and sine of some angle equals positive, oops, let me go ahead and fix that. There we go. Sine of some angle equals positive 1. Okay, I'm going to start with the negative 1/2 side. So we know sine is our y value, and y is negative down in quadrants 3 and quadrants 4. So negative 1/2 would be 7 pi over 6 and 11 pi over 6. So there's my first two solutions. My second two would be where sine is equal to positive 1. Well, sine is our y value, and sine is positive 1 at pi over 2 and 3 pi over 2. So it looks like we have 4 possible solutions. Now that we found our solutions using our unit circle, let's go ahead and write them out. Now if we remember what the problem said, it wanted solutions over the interval from 0 to 2 pi, or 1 revolution around the unit circle, and those are the ones we found. So our solutions are x is equal to 7 pi over 6, x is equal to 11 pi over 6, and that gave us 0 in the first factor. The second factor, our two solutions that made it equal to 0, were at the angles pi over 2 and 3 pi over 2. All right, so again, these are the solutions over the specified interval. Now, if we didn't have our specified interval and wanted all our solutions, all infinity, our general solution would simply be adding, so I'm going to go here and segment this off, we would add 2 pi n to get to our general solutions. There we go, I'll scribble that down to each one of these answers. Okay, if you have any questions, make sure you write them down and ask me in class. Other than that, thank you for listening.